Thank you for the opportunity to come here and talk to you about our project, the feasibility of afforestation and BECCS for greenhouse gas removal. I'm going to take the assumption that the audience both in here and online know that BECCS stands for biomass energy with carbon capture and storage, and I'm not going to go through the details of that as such. Just to say that we are, as a consortium project, these were the lovely individuals involved, and we are a consortium across the University of East Anglia, Manchester University, Exeter, Aberdeen and Aston. And I think we're probably like the most interdisciplinary of the four consortium projects. Each of the projects have a different a balance of social science and physical science and engineering, but I think we're the most balanced of all of them. Just to feed in then on the rationale between why we picked, sorry, I'm going to come out from the lectern because it annoys me, so I might be stressing out the AV, but you've got a roving mic on me, so it's fine. The rationale then is that afforestation and BECCS are in all low emission scenarios. So the future scenarios out to 2100, they are dominant. This is consistent from the 5th assessment report when we designed the project through the special report on 1.5 that some of our research fed into, and to the Working Group 3's publication just last month from the 6th assessment report. And so this is a figure on your right there. On the right, which I have borrowed from Glenn Peters that he's put out on Twitter recently. He's been digging around in the AR6 scenario database, and this is looking at the different GGR methods and how much they are in the scenario. So you can see on the top left is BECCS, bottom left is afforestation, top right DACS, and bottom right enhanced weathering. So you can see there both the dominance of BECCS and afforestation, but also I draw your attention to the ranges of uncertainty in those future scenarios as well. So the approach we took then was we essentially took those kind of scenarios, I've just inset that on the left there, and wanted to explore the real-world feasibility and consequences of them. And we did this by looking at 6 different kind of disciplinary approaches, but also 6 different elements of aspects of uncertainty in those scenarios. So life cycle analysis was led by Miriam Roeder at Manchester, then Aston. Land use policy, Brett Day at Exeter. The stakeholder component, I led that at UEA. Jason Chilvers led the societal and political aspects at UEA. Anna Harper led the global land surface modelling at Exeter, and Astley Hastings the crop process modelling at Aberdeen. Anna and Astley, I've already seen her in the audience today. So this allowed us to explore some of these uncertainties using the appropriate methods and tools to ask these questions, but at the core of it, what we used to keep these elements together was a common emission scenario, so 2 degrees C, assuming a middle-of-the-road global development, and we developed 4 supply chains together with our stakeholders, 3 different formulations of BECCS and 1 of afforestation. Now, what happened is in that emission scenario, we essentially prescribed where in the world the bioenergy would be grown for use in both the crop modelling and the land surface modelling. And so what we did was had a PhD who was able to explore some of the trade-offs and the drivers of land availability for BECCS and afforestation as a kind of separate but related component. We've published a lot. There are 30 publications, 5 more on my kind of list of things that are coming out. This is just peer-reviewed publications in journals that acknowledge the funding. There's also book chapters as well. And these range from geoscientific model development through to science, technology and human values, just to give you a sense of the spread of disciplinarity. So rather than go through lots of results, I've taken a different tack. And what I want to do is basically pull out some of the messaging that kind of repeated across the different pieces of research. Just to say, of those little list of headers of publications, one thing I'm particularly proud of is the amount of co-authorship across different work packages and institutions, which I think really reflected how well we work together as a group. So for afforestation first then, top right just there is a little, is our supply chain, which got the most critical feedback from our stakeholders when we first presented it to them, our first version, and got re-edited. And this is very much that vision that's implied, if you like, in the global scenarios, which is that you have currently unforested land that is then planted with trees to create a forest. What came up time and time again across different pieces of work around the afforestation then was that there are a number of kind of social drivers, actually. The afforestation question is not one necessarily about biophysically what can you grow, but it's about where can you grow that, which is driven driven a lot by that. I also think that the big difference between afforestation and BECCS, even today, right now, is that afforestation or tree planting is being led by society. Academia is playing catch-up on that, whereas BECCS is still much more kind of manageable in the realm of academia and kind of R&D and investment, whereas afforestation is something we are barely managing to keep engaged with, particularly around tree planting. So it's led by society, supported at the moment massively through voluntary offset markets, and also the kind of developing land use policies in the UK context, particularly with ELMS, for example. And it kind of matters, and there's a lot of diversity here about what kind of markets we currently have, for example, residues for feedstock, timber markets or carbon offsets. This is kind of driving a lot of the tree planting that you're seeing at the moment. There is a big question, obviously, for that, what land is available at both the UK and global scale for afforestation, particularly the competition for use with food, fibre production, with, for example, bioenergy crops or other things as well, and that was a key factor. Term we kind of came across a lot was the issue of real-world complexity. If you want to know the real-world feasibility, you get smacked in the face, I'm afraid, by the real-world complexity. Interesting bit of work that Laurie Waller did, looking for the kind of reference to afforestation in societal discourse, used some analysis of Twitter, some of grey literature, and he found it really hard to find that phrase. That phrase is used by climate policy people, by people who model things, but out in the wider societal discourse, the term used is tree planting. And that gives you a sense of the kind of varieties of real-life tree planting that happens. Urban trees, local amenities, there's lots of flood alleviation schemes, there's lots of reasons and motivations for tree planting and not just carbon removal. This is also reflected as an example of the interdisciplinarity here in a piece of work that Emma Littleton and Anna Harper did with other colleagues, looking at whether you want to go in from a kind of global kind of carbon cycle climate perspective. Do you want to go in and plant a tree, or do you actually just want to leave an area of land to go through natural succession and reforest itself? Versus also, rather than just thinking in this simplistic form of we need a new patch of land to plant trees, what about the inclusion of trees in arable or pasture agriculture as well? And so that's a nice example that this real-world complexity gets very messy very quickly, and any back-of-envelope calculations you see banded around usually are just wrong. The other thing we found, particularly looking at the kind of criteria that we should assess feasibility by, includes being mindful of co-benefits. And I think this really resonates with the afforestation, as I just said earlier, the other reasons tree planting is happening in the UK and elsewhere, such as the benefit for biodiversity, other ecosystem services, human health and well-being, and flood alleviation. Carbon is not always the driver of why people are planting it, or even if it is the driver, sometimes you might want to make compromises based on meeting some of these other objectives. So maybe take a bit of a hit on the carbon removed, but you'll get more benefits more broadly for society. So about BECCS then, these are the three supply chains we had, which allowed us to reflect the differences between feedstocks and different energy conversion processes. So there's quite a few angles of this real-world complexity was explored in some of the research then. For example, which biomass in our supply chains? We've got a forest residue, a willow, so a fast-growing tree species like willow or poplar, but this one we did willow, and a miscanthus that Ashley's modelling was focused on a lot. Where are you going to grow this? Again, as pointed out, we use quite a spatially explicit map in our emission scenario. But that factors in terms of climatology. But critically, what's the prior land use? Because it's your prior land use that will determine your land use change emissions, which will determine if your BECCS even actually gives you greenhouse gas removal. There was early on in the work that we published early on in the project, this kind of tension between the big numbers on feasibility often got stuck around the issue of assuming whether your biomass feedstock was coming from a forestry or agricultural residue equals no additional land use requirement versus a dedicated bioenergy crop. Similarly, there's nuances there about your crop yields versus climate and potentially the kind of impact of heat or heat stress on current breeds of miscanthus. This land availability dependence is not actually about physically what land is out there, but it's more driven by other kind of socioeconomic factors like dependence on food crop yields and diet changes and waste in the food system, which in turn means more or less land is abandoned from agriculture and made available for either afforestation or BECCS. But also critically, which of these energy conversion processes is your BECCS envisaged at the UK scale to come to fruition under? So that gets very tied, as we can see right now, with IDRIC and other things, into what the wider decarbonisation strategies are. So I think as a message overall then is that the social drivers are as important as the biophysical and technological aspects. They're listed there, but also I think a key message came out a few times is that this sustainable biomass is essential to deliver GGR, and to make sure the biomass is sustainable requires good monitoring, reporting, verification, but also strong governance. Finally, I just want to wrap up by saying that I think some of the things we think we did well, it was a good team of people, and we put a lot of effort and resource into the stakeholder engagement element, and the social science had an equal role rather than being an annex. And I think these both allowed us to improve the quality and the realism of the research conducted in what is a really fast-moving area, and definitely felt very fast-moving in the last 5 years. Tool-wise, I felt the supply chains really allowed us to think across the various scales and across the methods and models, and just to shout out to Supergen and Advent, because I think we really benefited from that. And finally, to just say that similar to what Phil started with, during the lifetime of the project, we were real-time feeding in our emergent results into various elements, particularly of national policy, as well as contributing to the IPCC's 1.5 report, for example, and this is just some of those. So I'm really proud of that. And I just realised as well, I'm the only female PI across GGR-A and GGR-D, and we had 3 periods of parental leave in different forms across the PI and work package leads and a postdoc. So I think we ticked all the EDI boxes as well fairly well for the programme. So thank you very much.